This video is going to go over two IB questions about reducing to fundamental SI units. And the first question is asking us to do that for the unit of electrical energy. Well, we know that electrical energy is measured in joules, so this question is essentially asking us, what is joules in fundamental SI units? From our data booklet, we have the equation of kinetic energy, which is 1/2 mv squared. So we can write an equation of units. Mass is measured in kilograms and velocity is meters per second, so we can write it as such. The 1/2 is not relevant here. Simplifying this, we get a joule is equal to a kilogram meter squared per second squared. This gives us answer choice C. There are other ways to solve this as well. For example, we could have used the gravitational potential equation. And in this instance, the unit for mass is kilograms, gravity is meters per second squared, and height is measured in meters. That simplifies to that same answer from earlier. The next question is asking us to do the same thing, but this time for a unit of electrical potential difference. For the first step, ask yourself what electrical potential difference is measured in. Well, since electrical potential difference is the same thing as voltage, also known as voltage, it is measured in volts. Voltage is equal to the electrical field value times the distance that a particle travels through the field. And the unit for electrical potential is a Newton per Coulomb, and the unit for distance is meters. And since we have to write newtons in terms of fundamental SI units, we know that force is equal to mass times acceleration, ma, which is kilograms times meters per second squared. Now this is in terms of units. So we can put that into our equation, and now we need to find Coulomb in terms of fundamental SI units. If you remember, Coulomb is equal to a ampersecond, so we can say that C is equal to AS. If you forgot that, you can derive that by saying that current is equal to charge over time. So a charge, which is measured in coulombs, is equal to current, which is measured in amps, multiplied by time, which is measured in seconds. Plugging that in and simplifying, we get answer choice C.